what if a machine could imagine motion? I'm not talking about just a static, single image, but the flow of time itself. You see, we've moved way beyond AI that just draws pictures. Today, it can generate entire videos from just a few words. So how in the world does this incredible technology actually work?
It really all boils down to this one huge question. How does a machine, a bunch of code and algorithms, learn to understand things like gravity or momentum or even the feeling of a story when it's never actually lived in our world? That's the core puzzle we're going to unpack right now.
So here's our roadmap. We'll start with what AI video actually is. Then we'll get into the key building blocks. We'll look at the wild process of creating from chaos, see how our words turn into pixels, talk about the big problems they're still trying to solve, and finally, peek into the future this is all leading to.
All right, first up, what exactly are we talking about when we say AI video?
Okay, so at its heart, it's all about prediction. The AI isn't just playing back a file it found somewhere. Nope, it's making a highly educated guess about what the very next frame of a video should look like based on all the data it's learned from. And it just keeps doing that again and again and again, creating this seamless illusion of motion.
Now, this is where it gets really different from what we're used to. In traditional animation, right, an artist has to painstakingly draw the key moments, the start of a punch, the end of a punch. With AI, there are no human keyframes. The model learns the statistical probability of how pixels should move over time. This is a fundamental shift. It's less about an artist having direct control and more about guiding a system that has this emergent understanding of how things are supposed to move. Okay, so to really get how that generation process works, we need to look at the three foundational pillars that hold the whole thing up.
These are neural networks, the kind of abstract idea of latent space, and the absolutely critical element of temporal consistency. Let's break each one down.
First up, neural networks. The easiest way to think about these is as the engine, or maybe even the brain of the whole operation. They're these complex mathematical systems that just get incredibly good at recognizing patterns after you show them massive amounts of data, like how a shadow should stretch when a person walks past a streetlight.
Second, we have latent space. Now, this one sounds really complex, but here's a simple way to picture it. Imagine a giant library. The library doesn't have every single book ever written, but it does have a perfect card catalog that organizes all the concepts: science fiction, romance, 18th century history. Well, latent space is the AI's version of that card catalog, but for visual ideas. The concept of a cat, or running, isn't stored as a picture, it's stored as a coordinate, like an address on this huge map of ideas. The AI creates new things by navigating this map.
And third, temporal consistency. Honestly, this is the secret sauce. This is the model's memory from one frame to the next. It has to remember that the person in frame 1 is the same person in frame 10, and that they shouldn't suddenly grow a third arm or have their blue shirt randomly flicker to red. Without this, you don't have a video. You just have a weird slideshow of disconnected pictures.
And that right there, that's the whole ballgame. Image AI has to understand space, how pixels are arranged. But video AI has to understand space and time. That's the incredible leap we're seeing.
So, let's get into the most popular technique that's used today and see how this all comes together. We're talking about a specific method for creating something from, well, basically nothing, or more accurately, from pure chaos. Most of the state-of-the-art models you've seen, like OpenAI's Sora, are built on this concept called diffusion. It's this super powerful idea that's become the go-to method for high-quality generation. And fun fact, it's inspired by a concept from physics, how particles in a gas just naturally spread out over time. So, how does it work? Get this, it's completely counterintuitive. First, the AI is trained to destroy perfectly clear videos by slowly adding random digital noise until they're just a mess of static. Then, and here's the magic, it learns how to perfectly reverse that process. So when you give it a prompt, it starts with a blank canvas of pure random noise. And, guided by your words, it begins to remove that noise step by step until a coherent video that matches your description literally emerges from the static.
So the crucial point here is this. The AI isn't just stitching together clips it has seen. It's not a collage, because it's building from pure noise and probability. It has the potential for genuine creativity, generating scenes and motions that may have never existed in its training data in that exact combination. It's a truly generative act.
But wait, how does it know what a corgi running on a beach at sunset even means? This is where we get into the magic of translating our human language into its mathematical world.
When you type in a prompt, it first goes to a language model that breaks down your words and converts them into a set of numbers, called vectors or embeddings. These numbers represent the meaning of your prompt, in that abstract latent space we talked about. Then, the video model's job is to shape that whole denoising process so that the final video's visual concepts perfectly match up with those numerical vectors from your prompt.
This entire process has a name: cross-modal learning. It's really just about building bridges between different kinds of data, in this case, text, images, and the dimension of time. It's how the text string dog becomes fundamentally linked in the AI's mind to the millions of ways a dog can look and move in the real world.
Now, this technology is moving at a breakneck pace, but it is far from perfect. Let's be real and look at the glitches in the machine, the really hard problems that researchers are tackling right now. One of the biggest challenges is long-term consistency. In a 3-second clip it might be fine, but in a longer one, a person's jacket might suddenly change color, or a car might inexplicably grow an extra set of wheels. Physics is another huge hurdle. You'll see a ball bounce and just float away, or a person's leg bend the wrong way. Human anatomy, especially moving hands and faces, is notoriously difficult. And of course, the sheer amount of computer power needed to train and run these things is just astronomical.
And this directly explains the aesthetic of so many AI videos you see today. They're kept short to avoid those consistency errors. They're often stylized or kind of abstract, which helps hide any weird physics. That signature dreamlike quality isn't always just an artistic choice. A lot of the time, it's a direct result of the technology's current limits.
But those limitations are being smashed at an incredible rate. So let's look forward to the coming reality and what this all means for the future of how we create and tell our stories.
We're already seeing major players like Disney investing heavily to use this for prototyping and making short clips. In just a few years, we could see video game worlds that are generated on the fly, totally unique to every single player. And looking out even further, this could evolve into a personal film studio for anyone who has an idea. The point isn't replacing creativity, it's about fundamentally changing the tools that are available to everyone.
And that leaves us with this final, really critical thought. The AI doesn't know what a sunset is or why it feels beautiful. It doesn't understand the physics of a wave crashing on the shore. But it has analyzed so much data that it has learned with incredible precision what reality usually looks like. And its ability to convincingly recreate that semblance of reality, well, that's only just beginning.